We're at a testing site in North Korea. It's set in the mountains and has 3 visible tunnel entrances known as the South Portal, the East Portal, and the West Portal. It was through these hook-shaped tunnels that the Korean military brought the device deep under the mountain. After that, the tunnels were filled in to stop any radioactive material from leaking because the devices were part of a thermonuclear bomb. And then there was an explosion. Its epicenter was more than 1,470 feet below the peak of Mount WATOP. The blast basically vaporized the granite rock in a chamber about 164 feet wide, roughly the size of a football stadium, and damaged the surrounding rock in a zone about 980 feet across. The explosion likely lifted the mountain by 6 feet and pushed it outward by about 10 to 13 feet, though the rock later caved in. In the end, the underground blast led to a partial collapse, followed by compaction that lowered the mountain by 20 inches. The blast also triggered a 6.3 magnitude earthquake and sent out shock waves loud enough to be picked up by seismologists all over the world. North Korea's nuclear tests also caused tremors in Chinese towns and villages near the border. People said they saw tables and chairs shaking for a few seconds, and some companies even evacuated their staff from the offices. High school students were also dismissed during an exam after a crack emerged in the recreation ground. Naturally, all of this came as a total surprise to anyone not involved in the tests. But that wasn't the end of it. Give me 5 seconds. I'll make some coffee and we'll keep going. Just an unobtrusive reminder to hit the like button if you tend to forget by the end. So on September 3rd, 2017, a nuclear device was detonated inside a mountain. North Korea tested a powerful hydrogen bomb, which could in theory be loaded into an intercontinental ballistic missile and used against foreign enemies. This underground nuclear test was the biggest in North Korea's history. Since there's no exact info about it, as North Korea doesn't just share that kind of thing, experts have to figure out the details using their own calculations. For example, Mount WATOP is 7,200 feet high, and according to estimates, the nuclear device went off right under the peak at a depth of 1,300 to 2,100 feet. The bomb's yield was between 120 and 300 kilotons of TNT. To get a sense of the scale, the bomb dropped on Hiroshima is believed to have had a yield of around 15 kilotons. Some info even came in from official sources. North Korea's state media reported a successful 2-stage test of a thermonuclear bomb. In a TV announcement accompanied by patriotic music and images of North Korean landscapes and military gear, it was said that the test had been carried out on the orders of the country's leader, Kim Jong-un. Not that anyone had any doubts. It was a test on the Punggye-ri site in the northeast of the country, under a mountain near the border with China. The location was confirmed by the University of Science and Technology of China. Using data from 112 earthquake monitoring stations in China, scientists said they're confident the test was carried out exactly at Punggye-ri. This isn't the first time the seismic lab at the University of Science and Technology of China has pinpointed the location of nuclear blasts in North Korea. In fact, Chinese scientists have successfully identified every nuclear test North Korea has carried out since the first one in October 2006. The Punggye-ri nuclear test site is considered North Korea's only nuclear testing ground. It's located about 230 miles northeast of Pyongyang. But Chinese experts didn't stop there. In 2018, they conducted a study and found that North Korea's nuclear test site partially collapsed due to multiple explosions. This may have made it unsafe for further tests and vulnerable to radiation leaks. And I say may have because, well, one can only guess. Some analysts have even noticed signs that WATOP Mountain, the peak under which North Korea detonates its nuclear bombs, is suffering from tired mountain syndrome. This is a special diagnosis that was previously used for the atomic test sites of the Soviet Union. The idea behind it, simple. Underground nuclear explosions significantly alter the properties of the rock mass. This leads to the formation of cracks and the destruction of rocks, as well as changes along tectonic fault lines. Chinese experts claim that WATOP Mountain shifted noticeably during the last nuclear test. They also warn that further nuclear tests could lead to the complete collapse of the mountain and a powerful radiation release. And this isn't an empty concern. As I mentioned, part of the mountain sank during the test, which not only shows the power of the charge, but also the weakness of the mountain. And it's not just about losing one peak on the planet. In an interview with South China Morning Post, Wang Naiyan from the China Institute of Atomic Energy said that there's a real risk of a major environmental disaster that could affect not only North Korea, but also spill over into neighboring countries. If the mountain collapses and a hole opens up, everything the rocks were holding inside will burst out, like steam coming out of a pot when you take the lid off. And it seems like that's where it's all heading. Satellite images published in 2017 by the authoritative site 38 North showed that the test under the mountain caused landslides around the explosion site, although there was no visible crater to indicate a collapse. Then 38 North published satellite images taken a little later. They already showed changes on the surface of the Punggye retest site, where the ground had been lifted into the air by the underground tremors. This is what satellite images of the mountain look like on September 1st and 4th, before and after North Korea's last nuclear test deep under the mountain. Experts also say that all these rock disruptions and landslides are more numerous and extensive than anything ever observed before. Fortunately, after that, the Chinese authorities stated they didn't find any radiation risk in the samples collected along the border, although the effects were felt for a long time afterward. Using advanced analysis methods, scientists discovered that the North Korean nuclear bomb test caused aftershocks for the next 8 months. The test itself and the collapse were recorded by seismometers around the world and widely covered. Only later, quietly, seismological stations managed by China, South Korea, and the United States detected over 10 weak tremors. All of them were apparently scattered within a 3 or 6 mile radius of the test site. The first two happened on September 23, 2017, and the last one on April 22, 2018. Scientists suggested the bomb shook the Earth so much that it took a while for the ground to calm down. It's unlikely that so many events, completely unrelated to each other, happened in such a short time on this small area. I mean, earthquakes happen on their own, sure, but when someone's just detonated a hydrogen bomb, well, you kind of start to suspect something. All the tremors were moderate, with magnitudes ranging from 2.1 to 3.4, and most likely harmless. In the past, it would have been hard to detect them with remote seismometers, but modern technology can do even more. Plus, the explosion's power was probably different from those in the past. There have even been reports that the nearby volcano, Mount Pictou, is at risk of erupting. It showed signs of unrest, and a few volcanologists who visited the site were also worried about the seismic activity nearby. Moreover, Mount Pictou has had several catastrophic eruptions in the past. According to a study in Scientific Reports, the powerful tremors caused by military tests could wake up this sleeping dragon. This is because the shock waves created by the explosion spread in all directions, including to the magma source beneath Mount Pictou, 72 miles away. Scientists point out that such shock waves could hypothetically disturb the magma, which is already under significant pressure deep beneath the Earth's surface. And when the internal pressure of the magma exceeds the restraining pressure of the surrounding rock, an explosive eruption happens. At that moment, the rock cracks, and the vault of the chamber collapses, causing sudden decompression and the release of magma and gas. Using a series of mathematical models, researchers calculated that one more powerful underground nuclear bomb test would be enough to slightly increase the pressure in the magma chamber, and then boom! It's hypothetical, of course, but it's still alarming that even a slight increase in pressure might be enough to trigger an eruption. The last time Mount Pictou erupted was in 1903, and while everything seemed to be fine then, with no casualties or destruction, that's no reason to intentionally disturb it. However, some experts think the scenario of a triggered eruption is unlikely. According to them, if the molten rock isn't activated, even a strong earthquake won't cause any awakening of Mount Pictou. As an example, they point to the 2011 Tohoku earthquake with a magnitude of 9, which, however, didn't lead to the eruption of any of Japan's numerous volcanoes. Well, sounds logical. But who knows what other nuclear tests North Korea might have planned? Actually, North Korea was the first to withdraw from the Treaty on the Non-Proliferation of Nuclear Weapons. This happened back in 2003, and since 2006, the DPRK has been conducting underground nuclear tests with increasing intensity. The magnitude of the earthquake from the 2017 test was much higher than from any of the previous 5. From 2006 to 2016, North Korea steadily increased the scale of the events, somewhere from 1 kiloton to 20 kilotons. The earliest events seem not to have worked as expected because they were unusually small, Then, in just 1 year, the power shot up to 250 kilotons. This is what Mount Montopson looks like, and all 6 nuclear test sites, including the biggest test on September 3, 2017. But what do we know about the others? On October 9, 2006, the Korean Central News Agency reported that the country successfully carried out a nuclear test at the Punggye-ri nuclear test site. The U.S. Office of the Director of National Intelligence estimated that the explosion's yield was less than 1 kiloton, and the test took place in the eastern tunnel about 0.6 miles north of the entrance. The overburden was estimated to be 1,000 feet thick. The second nuclear device was tested on May 25, 2009. At that time, the U.S. Geological Survey estimated the seismic activity caused by the test at a magnitude of 4.7. This time, no inert gases were detected in the explosion, meaning scientists couldn't say for sure whether plutonium or highly enriched uranium was used. However, it was known that the bomb's yield was about 4 to 6 kilotons, and the explosion happened in the west tunnel about 0.7 miles northwest of the entrance. The overburden was estimated at 1,600 feet this time. On February 12, 2013, North Korea conducted its third nuclear test at the Punggye-ri site. This test was recorded by the United States Geological Survey as a tremor with a magnitude of 5.1. 55 days after the explosion, xenon 131M and 133 were detected at radionuclide detection stations in Japan and Russia, but by the time they were detected, they had degraded too much to determine whether the device used plutonium or highly enriched uranium. Then on January 6, 2016, North Korea conducted its fourth nuclear test. At that time, the authorities officially stated that it was a hydrogen bomb test, which marked a significant advancement in the country's nuclear program. However, experts were skeptical of this claim given that the earthquake caused by the test was about the same strength as the previous one. Later that same year, on September 9th, North Korea carried out its fifth nuclear test. According to the United States Geological Survey, the magnitude of the test was 5.3, making it more powerful than all previous North Korean tests. Estimates suggest the explosion had a yield of between 20 and 30 kilotons. Naturally, all of this analysis, just like the 2017 test analysis, was done remotely, far from the North Korean site for obvious reasons, and it was in 2017 that complete 3D images of surface displacements related to the underground nuclear test were first obtained and presented to the public. The game-changing technology that enabled this analysis is called synthetic aperture radar. To make it work, the team merged seismic data with before and after satellite observations from Germany's TerraSAR-X and Japan's ALOS-2, both of which carry SAR on board. Unlike regular optical satellite imagery, SAR can measure Earth's deformation both day and night in any weather. This allowed them to measure the full three-dimensional deformation of the Montopson mountain surface. This is what the image looks like. The arrows indicate horizontal displacement, and the color represents vertical movement. The red stars show the spots of previous nuclear bomb tests. Still, it's not enough for a complete analysis. Unknown characteristics of nuclear devices, test sites, and their geological context create a lot of uncertainty when it comes to assessing the explosion's power. For example, in 2017, they estimated the explosion's power is between 30 and 300 kilotons. That's quite a big spread, don't you think? The U.S. intelligence community assessed the explosion's power at 140 kilotons. Meanwhile, U.S. intelligence typically applies an uncertainty range of a factor or two to reported estimates. That is, if they say the yield's 100 kilotons, it means the bomb could be anywhere from 50 to 200 kilotons. A more recent study estimated the yield of the 2017 test in the range from 148 to 328 kilotons. So what happened next? On May 24, 2018, North Korea said it had demolished the test site in advance of the first U.S.-North Korea summit, with international reporters there to witness it. But over 3 years later, construction activity was spotted at the site again. As of April 11, 2023, there were still no signs of any upcoming tests, even though the site likely could support them if the leadership chose to go ahead. 3 tunnels were blown up in a series of explosions right in front of around 20 carefully selected international journalists. 2 blasts went off in the morning, and another 4 followed in the afternoon. The tunnel doors were theatrically rigged with wires everywhere just to make sure the journalists noticed. They were positioned to watch the explosion from about 1,640 feet away. 3, 2, 1. And then came a powerful blast you could actually feel. Dust, heat, a deafening roar, and the tunnels were sealed shut. Later, it was confirmed that there was no radioactive leakage and no negative impact on the surrounding environment. Well, the degradation of a mountain doesn't necessarily mean it'll be abandoned as a test site. For example, the U.S. didn't leave the Nevada test site after earthquakes. On the contrary, they kept using it until a nuclear test moratorium came into effect in 1992. What's more, previous Korean tests were carried out through the northern portal into underground tunnels. Even if those tunnels had collapsed, North Korean nuclear scientists could still have used tunnel systems connected to the south and west portals, and there's always a chance they'll build a new nuclear test site. And then satellite images might turn out useless, since there are lots of other mountains in North Korea that could be used. You just can't keep track of all of them at once. Still, hiding new underground tests wouldn't be possible. You can cover up the test site, but not the shockwave and aftershocks. You owe me a like. See you later.